A-Level Chemistry Paper 3, 2017, AQA. Suggests one reason why the enthalpy change of this reaction cannot be determined directly by colorimetry. Not possible to prevent some dissolving. Magnesium chloride, hydration, not possible to prevent some dissolving. Calculate enthalpy change. So the enthalpy change in this case of hydration is going to be minus 155. So we're going to go the other way, minus 39 arrow. So we should get minus 116. The best way to do this is just to draw obviously a cycle. This is no cycle. Question 1.3. Describe how you could carry out an experiment to determine the enthalpy of solution of anhydrous magnesium chloride, and then how your results could be used to calculate the enthalpy of solution. 6 marks. Stage 1, the method. Measure water with a named appropriate apparatus. So this could be anything, right? Just a named appropriate apparatus. Suitable volume in range 10 to 200 centimeters cubed. Into polystyrene cup, or you could say an insulated container, say polystyrene cup. Add known mass of magnesium chloride, see solid, and use of before and after weighing method, not added with washings. Stage 2. Measurements could mark from diagram. Record initial temperature, intervals of 2 minutes. Record initial temperature intervals. Record initial temperature. Record temperature at regular time intervals for 5+ minutes. Plot T versus time. Stage 3, use of results. Extrapolate lines to when solid was added to find initial temperature and final temperature. Obviously delta T is final temperature minus initial temperature. I'm not going to write that down because I could actually delta T temperature final minus temperature of initial, and obviously we find it from the graph. Find from graph, and where is it from the graph? At point of addition and then obviously Q, to find Q is MC delta T. I've got delta T, and then we find out the moles. Moles is mass over mol. I have 0.8 grams of magnesium chloride divided by the MR, 95.3. That'll give me 8.39 times by 10 to the power minus 3 moles. And what are we trying to find? We're trying to find the enthalpy of solution. So the enthalpy of solution is going to be Q divided by number of moles, and Q is obviously MC delta T. So it's going to be minus Q divided by 0.39 times by 10 to to the power minus 3. And the reason it's minus is because we know that we know these ones are negative. Temperature increases. 1.4 uses data to plot a graph of 300 change against temperature on the grid. Calculate gradient and hence calculate entropy change. Okay, so if we plot the graph, and it gives us the x-axis and y-axis, so that's pretty nice. Look here, point here, 1 at 260, and obviously it's just plotting graphs, which I'm just going to copy from the mask scheme here, otherwise it'd be a waste of time. Okay, and it should actually be a lot higher, minus 592 here. Not completely accurate, and you know, you should get the point, but it should be a straight line, right? It should be a straight line. But yeah, this is testing your graph skills. And now in order to find out, calculate the gradient, y2 minus y1 over x2 minus x1, to calculate entropy change, well, we should know gradient in this case is going to be delta G divided by delta T. So therefore, to find delta S, well, we find out the gradient, I get 0.167, and delta G is delta H minus T delta S. So, and the gradient is going to be minus delta S. So delta S is going to be minus 0.167, but that's kilojoules, and we want it in joules, so it's going to be minus 167. Name the mechanism for reaction of concentrated sulfuric acid with an alkene, that is electrophilic addition. Nice one, marker. Okay, now it says 2.24 marks. Outline the mechanism for reaction of concentrated sulfuric acid with propene. So we got propene, so we got C11C H3 CH3 H 1 2 3 3 4 5 6 propene, yes. And obviously you've got your S double bond O double bond O OH and your O and your H here. And what happens, it goes from the double bond to here, transfer the electrons to the oxygen, and what you get now is you get this. You've got obviously you've got your CH3 group here, you've got your H, and you've got a H here, and a H here, and this second carbon is positive because we want to form the major product. If the carbocation was here, that wouldn't be the major product. Same as here, but because it's here is the major product. It's got two alkyl groups, so it's here, and then you've obviously got the oxygen minus charge, lone pair of electrons, S double bond O, double bond O, OH, and then obviously it goes from lone pair of electrons to the carbon, that's a positive charge, and then you form. Then it's just bonds to it, so you've got your CH3, H3C, CH2, no CH, CH3, and then you've got your OS, double bond O, OH. So double bond to H, then to oxygen. Obviously, one of the major products of the second carbon is going to have positive charge of the carbocation, and then just bonds to lone pair of electrons, bonds to the carbon. And then these 1 markers, which the part I struggle with, maybe you guys do as well. Drawing the structure of the minor product formed. Well, if it was the minor product, well, it wouldn't be on the second carbon, it would be on the first carbon. So the minor product, all it's going to be CH3, CH2, CH2, OSO3, OSO3H. So for the structure, oh, it says draw the structure, yeah. So we've got CH3, got CH2, got CH2, and obviously the oxygen in this case is going to bond to the first carbon, so it's just going to be O and S, double bond O, OH, or CH3, CH2, CH2, O, SO3H. Explain why your product in your answer to question 2.2 is a major product. Well, major product formed via more stable carbocation, or you could say secondary I'll say this as well. Secondary carbocation is more stable than primary carbocation. Remember, it's primary, second, tertiary strongest, secondary second strongest, and primary is the weakest carbocation. Now, why is this so? Okay, because secondary carbocation is more stable due to the due to the positive inductive effect of 2 methyl groups as opposed to one methyl group. Draw the skeletal formula of each of the isomeric alkenes from the reaction between butane 2-O with concentrated sulfuric acid. So butane 2-O reacts with concentrated sulfuric acid. We're going to form but-1-ene, because obviously we're going to form an alkene, 2-ene, but-2-ene, but this is going to be the E isomer. I'm going to have a Z but-2-ene. For but-1-ene, methane, ethane, propane, butane, but-1-ene. E but-2-ene, same thing, but it's going to be the second carbon. It's going to be here actually. Yeah. Z but-2-ene, well, it's going to be here. Name this byproduct. Molecular formula this, butanone. Identify role of sulfuric acid. Oxidizing agent, not catalyst. Name a separation method, fractional distillation. Iodine, sulfur, and hydrogen sulfide. need to find the mass, density of mass of volume. Mass is going to be density times by volume. That's of the ester. But the amount of sodium hydroxide is 0.06. Just by doing 30 times by 2 divided by 1000 concentration and volume. So therefore, sodium hydroxide, in excess of it is used in this reaction. So just when excess of sodium hydroxide is needed, to ensure that all the ester reacts. So just when electric heat is used rather than a Bunsen burner's hydrolysis, what are we working with? We're working with ethanol. And ethanol, you should know, is very flammable. times by concentration of Hx, 0.0960. Get a concentration H plus sign, and pH is minus log 10. Concentration H plus sign, substitute that into there. Should get a pH. Obviously, we want it to 2 decimal place. It must be 2 decimal place or more decimal place. 2.80 to 2 decimal places. Calculate pH and half the acid reacted. Well, in this case, pH at half neutralization is equal to pKa. So it's going to be minus log 2.62 times by 10 to the power minus 5. Minus log 10, obviously. 4.58. Again, 2 decimal places. pH always in 2 decimal places. And then it says plot your answers to questions that are on the grid, and then use points to sketch the missing part of the curve. So yeah, you just plot it. So pH of Hx and that, and then what we want us to do, sketch the missing part curve. Yeah, just a graph question, I'm therefore going to skip it. And that's the end of the past paper question.